G'day everyone, today's we're working on Radian Measure. So what we're doing on Radian Measure is looking at another way to look at angles. Up until now all we've used is degrees, and degrees we're probably fairly familiar with, that we've got 90 degrees which would be a right angle, 180 degrees is a straight angle, more than 180 degrees it becomes a reflex angle, and then back to 360 for a full revolution. So hopefully you're familiar with that, and the sine, cos, tan stuff that we've been doing up until now has all been in degrees. Now degrees is fine and works okay, but as you get further in your maths, radians will become the way that we use it. Radians, especially for those doing specialist courses, advanced maths, will be the way that you do things. So let's have a look at what we're meaning by radian measure. Now straight away with the word radian, it's very similar to radius. Talking about circles, radian means kind of around the outside. So when we look at it, we've got the circumference equals 2 pi r. We know that formula, that's around a circle, no issue there. But what is that actually really meaning? Isn't that 2 pi lots of r? Think about that, 2 pi lots of r. Well, if I've got my diagram of a circle, here's my radius. Doesn't matter where around the circle I go, but here's my radius. So does that mean that 2 pi lots of r must go all the way around this circle? Now 2 pi is about 6.28, right? 3.14 times 2. So then from there, 1, 2 lots of the radius, 3 lots of the radius. Notice that I'm just short of the halfway line. So that would be 3.14 lots of the radius, wouldn't it? But here's my third lot, my fourth lot, my fifth lot, my sixth lot, 0.28. So I'm getting 6.28 lots of the radius will reach all the way around the circle. That's what we're talking about when we're talking about radian measure. We're saying, well hang on, let's base the measure around the outside. So whereas with degrees, if we had some angle in here, degrees, you'd be measuring the angle in the middle. But with radian measure, we're measuring it based upon how many radiuses fit in the outside around there. Alright, so you see how it's measuring from the outside rather than the inside. Still talking about the same angle, still talking about the same space inside, etc., etc. But we're measuring around the outside in terms of how many lots of the radius fit around that circumference. Now, with that idea in mind, a radian measure of 1 is going to be whatever the radius is there, and it actually doesn't matter what the radius is, because that size of circle I've drawn, if I drew that circle a little bit bigger, well then the radius would be bigger, but the circumference would be bigger as well, wouldn't it? So the distance around the outside to 1 radian would still be the same. So the size of the circle, you might think, well hang on, doesn't that change with the circle size based on what will fit around the outside? Well yes, the circumference changes, but also the radius changes. So therefore, whether this is drawn at this size, smaller or larger, 1 radian around the outside connects to the same angle in degrees based in the centre. So there's not actually any change. Sometimes students think, oh but wait, hang on, the circle size will change what's going on. Not at all. So we're having a look here. Let's convert degrees into radians. Well, if we've got 2 pi lots of r going around the circle, isn't that really saying that 2 pi radians will equal 360 degrees? Because 2 pi is how many I take to get around. Well, that's the same as 360 degrees. See the radians and the degrees as you're going to substitute into one of those. So if you want to work out degrees, you're going to be dropping some radians, 1, 2, 3.5, 4, whatever, into there. So it's a bit like a, I don't know, speed, distance, time calculation. You're going to put some things in and work the other one out. If we simplify this a little bit, we can come out with pi radians equals 180 degrees. Well, that's just half of both of them, nothing special there. Let's do some conversions here. So we're converting the following 2 radians. So if I've got 90 degrees here, hopefully you can see from this one here, 90 is half of this. So wouldn't that be equivalent to pi over 2 radians? And normally sometimes you'll write a little r just to signify that it's radians. If it's a decimal, sometimes you'll put it up the top there. Once you get a bit better with your radians, it won't really matter because you'll see the pi and you'll straight away go, that's in radian measure, I know what I'm on about. But sometimes you'll see a little r up the top to signify radians, just like we put a little circle here for degrees. 180, well, that's already right here. That's just going to be pi radians. Now 135, these ones weren't so bad. We could kind of see it. But in order to convert from degrees to radians, really what I'm doing is I'm taking this, whatever the degrees is, I'm dividing by 180, and therefore I get the number of radians that I need. And you can see that's going to work here, isn't it? All right. That 90 divided by 180 is a half, so it's a half of pi. So 135, and I chose that specifically because isn't that 3/4 of 180? 135, 3/4 of 180. So I could do this, I could go 135, that's not a very good pen, let's go again here. 135 over 180, that's going to get me my 3/4, and then I recognise that it's going to be 3 pi on 4, or 3/4 of pi. Just I did much the same here. It's just that 180 divided by 180 came out to be 1. This one came out to be half. I'm doing much the same thing here. So let's show these on a circle here. A here, pi on 2, right? Well, I know that 90 degrees looks like that. So pi on 2 radians, you've got to recognise it's going to look exactly the same. So from there around to there is half of pi. And remember that there's 2 lots of pi all the way around. 1 lot of pi would get me to here, 3.14. So half of pi, it makes sense that that's going to be 90 degrees. The second one here, 180, well, it doesn't matter. I started here, and we do with our unit circle start there. It doesn't actually matter where I start. Here we go, I'll start there. If I'm going to show pi on that one, well, that's just going to be right across the centre. Around there is going to be pi. Doesn't actually matter, I could have gone the other way as well. Doesn't really matter. Last one, 3/4 of pi. Okay, so it's less than pi, so it's less than this, but it's more than half of pi. So really, again, I'll start at a random spot here. So then 90 degrees, or pi on 2 would be there. 180 degrees would be there, or pi. So therefore, 3/4 of pi would be that one there. So that angle in there is 135 degrees, and that there is going to be 3/4 of pi. Notice again we're measuring degrees in the middle, radians on the outside. Converting the other way, well, when we did this, we divided by 180, didn't we? We kind of divided by 180 and added pi in there to signify that it's lots of pi. Well, wouldn't we do the opposite here? Wouldn't we multiply by 180, and that's the pi idea? So if we multiply that by 180, we'd get 360 degrees. And again, doesn't that make sense right back over here? Pi, 2 lots of pi is a full rotation. 360 degrees is a full rotation. So multiplying by 180 works here. This one, isn't that going to be 180 degrees divided by 3? Replacing the pi with 180, getting me 60 degrees. Same again, replace it. 2 lots of 180 is 360, divided by 2 is going to be 120. This one here, 7 pi on 3. Have a think about that, 7 pi on 3. Isn't that 2 1/3 pi? And isn't 2 pi a full revolution? So 7 pi on 3 is going to be more than a full revolution. Let's see how it comes out. 7 times pi, well 7 times 100 is 700. 7 times 60, 7 6s are 42, 420. The 700 add the 420, 1120. Hope I've got that right. Divided by the 3. So 1120 divided by 3, well 1200 divided by 3. I've moved it up a little bit. 1200 divided by 3 would be 400. So then it's going to be a little less than that, isn't it? So whatever it comes out to be, 370, 380, something like that, is what it's going to be. Okay, we can work it out exactly. I can't off the top of my head, but I know it's going to be 380-ish degrees. And that makes sense because it's greater than 360. 7 pi on 3. We know that 2 pi is a full revolution. So just doing the numbers here, 2 1/3, more than 2 pi, more than a full revolution, something about that is going to come out. That makes sense to me. That's Radian Measure. Hope that video helped.